Hello, welcome to this follow-up video. So hopefully by now you've had a look through the additional exploring data worksheet and the additional exploring data output, which is on this document here, and you've had a go at answering those questions. So I'm just going to talk through some key things to look for and what you can do with each table, and I'll talk a little bit about reporting. But it's really important that you've had a go before you watch this video. A lot of SPSS and interpreting statistics is about practice and trial and error, so the more you can have a go at it, the easier it will start to become. Okay, so this is the output that you needed to explore. So we have our descriptive statistics, tests of normality, tests of homogeneity, of variance, and a variety of histograms and box plots produced separately for males and females in our sample, for a positive effect variable and a negative effect variable. If you want to learn more about positive and negative effect, what they are and what they mean, I'd have a look back at the activity sheet. There's a link to a blog post which talks about the PANAS, which is one of the most commonly used measures of positive and negative effect. Okay, so the case processing summary, what it tells us is it gives us an idea of how many males and females there are with complete data and missing data on both of our variables. So for the first variable, positive effect, we can see that we have valid data, complete data for 160 males and 198 females. And when we look at the missing cases, there are 0 for both. So there's no missing data for males or females on the positive effect scale. We look then to the negative effect scale variable. We can see again that there are 160 males and 198 females. And again, looking at the missing data, there's no missing data for either males or females on that variable. So that's a really good picture. Missing data is an important thing to look at. That's because it can mean that there is bias creeping in to your results, because some people have taken part for whatever reason for each question or each questionnaire, but some people haven't. So missing data is something that's really important to pay attention to. The next table we have is the descriptive statistics, and the first sort of section of this looks at the positive effect variable. So I'm going to just look at positive effect from now on, and then you can apply how I'm interpreting this to the negative effect schedule as well. So looking at the positive effect, what we can see is that the mean score on that for males was 33.39, and the mean score for females was 33.77. So those are very similar to each other. But what we're really interested in as well is trying to identify what the distribution of the scores for males and females looks like. And one of the first things that I usually check is the 5% trimmed mean and compare that in relation to the mean score here. So the 5% trim mean is where the 5% tail of the distribution has been chopped off. So if you have any really extreme scores, what you'll see is a big change between the mean and when those extreme scores have been cut off. So what you're looking for is there a big difference between the mean and the trim mean values? And if there is, then that's more of a cause for concern. What we can see here is for the males, we have a score of the mean for 33.39, and the trim mean is 33.65. So there has been a slight change, but it's not huge. So again, that's not too concerning. I'll also look at something called the median value, which is sort of the mid value of the data set. And in a normally distributed variable, the mean and the median will actually be perfectly the same. They would, that's very unusual, but what we're looking for is that they're similar to each other. That would suggest that, again, that's another good sort of tick in the box for normal distribution. We can see here that the median score is 33 compared to the mean of 33.39. Again, that's similar. So these are all good things. I'm looking at the standard deviation. What that tells me is that most people will, so you've got the mean score here of 33.39. Most people are going to fall between plus 7.3 points on the positive effect schedule above the mean and 7.33 points below the mean. So it gives me an idea of how dispersed all the scores are around the mean, and APA style recommends that those two things are reported in combination. So whenever you use a mean, you should report your standard deviation too. So there's some other important information here, minimum, maximum range and interquartile range, but I'm going to skip over those here now. What I'm going to look at instead is the skew and kurtosis values. Now what we're looking for, usually, but not always the case, but usually if the value of skewness or kurtosis is within plus or minus 1, that's a good sign. As soon as the value starts to creep over those, then the skew and the kurtosis become more substantial and they're more likely to be problematic. What we can see here is that we have a value of minus 0.48 or 49, sorry, for skewness and 0.298 for kurtosis. So what that suggests is that they are within the plus or and minus 1 boundaries. So that's a good sign, but they're not perfect. So if there was absolutely no skew, so a perfectly normal distribution, we would have a score of 0 for skewness and a score of 0 for kurtosis. But in practice, that never happens. So what this tells us is that for the male score for skewness, for positive effect, there is a slight negative skew. What that means is if you're looking at the distribution, when we look at the histograms, we should see this, there'll be a longer tail towards the left-hand side of the graph. Okay. What we can see for kurtosis is this is a positive number, and what that probably means is that the distribution is slightly pointier than we would expect the normal. But again, they're within those plus and minus bounds. So just looking at the female scores here then, on positive effect, we can see, as we said earlier, a mean of 33.77, and we can compare that to a 5% trimmed mean of 34.09. So there is a bit of change between those two things. It's not huge, but we might want to have a look and see if there are any outliers in our data set. And that's usually most easily detected through our histograms and our box plots. We'll compare that as well to the median. We can see that there's a value of 35. So actually our mean, our trimmed mean and our median are all fairly similar. There is a slight change, but they're all quite similar to each other. So that is a good sign, but we'll need to do a bit more digging before we know for sure. We'll also look at the standard deviation. We can see a standard deviation there of 8.050. So what that means is that a large proportion of our data, people will fall plus 8 points above or 8 points below the mean score. So it gives us an idea of how spread out our data is. So what we can see then is there's a slightly more spread out distribution around the mean for females compared to males, but it's not huge. But we will test that with our homogeneity variance test that we asked SPSS to produce. So we look at the skew and kurtosis values again. So we can see that neither of those are 0, so there is some skew, there is some kurtosis present. But they're within the plus and minus 1 boundaries, which is a good sign. But what we can see here again is some negative skew. So we've got a figure of minus 0.5 for skewness for the female participants data. So that suggests that there would be a longer tail to the left-hand side of the graph again when we look at our histograms. The kurtosis value this time is negative. So we've got a value there of minus 0.163. So that suggests that actually we may have a slightly flatter distribution than would be expected if it was a normal distribution. So we'll need to have a look at that when we look at our histograms. So I'm not going to look at the negative effect scale variables, negative effect scale variable for males and females now, but have a go at that yourself. So pause the video and draw your own conclusions, as I have just done for the females. Write down some notes about what you think these descriptive statistics tell you about the data so far. Okay, so hopefully you've paused that, you've had a go, and now we're going to move on. So we're going to look at our test of normality, and again we're only going to look, only going to look at the positive effect scale total score. So what we can see here, we have a male and female row of statistics. Now, The argument usually is that if you have a very small sample, which is 50 participants or observations or fewer, then it's arguably safer to use the Shapiro-Wilk test. Once you start to have samples larger than that, you can really use either. So we have a sample that's much larger than that, even when we break it down by male and females. So we've got 160 males, 198 females. So what we can do is we could use either of these. So I'll look at the Kolmogorov or Smirnov test for now. What I'm looking to see is, does this test of normality suggest that my data is significantly different from normal? So what I'm looking for from this test is if this significance value here, if that value is 0.05 or smaller, then it is statistically significant, and that means the data is significantly different from a normal distribution. So we can see here for the females, that value is 0.000, that's the lowest significance value that SPSS can report or does report by default. So we know that that is less than 0.05, that is statistically significant. So it would suggest that our data is not normally distributed on positive effect for the females. So we're very much borderline here for the male score, but it's not a great sign. So that's 0.053, it's technically just over 0.05. But what we could say is, well, it's probably not going to be normally distributed. However, one of the issues with test normality are that the larger your sample, the more likely they are to just say that there's something going on, even when the deviation from a normal distribution is only tiny. So we don't want to put too much weight on this test result at the moment. We need to look at everything. Remember, our descriptive statistics suggested that the data might be fairly normally distributed, so we need to do a bit more digging before we can make any draw any conclusions. So I'm going to skip over the test homogeneity of variance for the moment, and I'm going to continue on this sort of vein of thought about the normal distribution, and I'm going to look at the histograms and the box plots. So what we can see here is the histogram for the male participants on positive effect. And we can see the normal distribution curve. So there is something, it's not perfectly normal, but actually I would be looking at thinking it does follow roughly a normal distribution, so I wouldn't be too concerned at this point. There is potentially something going on in terms of there's a dip in the middle here, but it's not too concerning. So we'll look at the female distribution. So the female distribution, again, there's that sort of tail to the left hand side, as we can see in the male distribution as well. There's a longer tail to the left, and that's negative skew. And there's a peak here. Again, it's not perfectly normal, but it's perhaps not too concerning. This is slightly less normally distributed than the other variable, but it's perhaps not too concerning. And looking at our box plots, what we can see here is that if we had a perfectly normal distribution, this line here would be smack bang in the middle. The tails of these box plots, or the whiskers as they're also known, would be of equal length, and the box then would be, so there'd be an equal amount, an equal length with the box above and below that line. So it would be in the middle, and pretty much everything else would be symmetrical around it. We can see that that's not quite the case. It's perhaps slightly more normal for the males, although what this is pulling out here is that we have some mild outliers. We have at least 3 mild outliers, and if these had been an asterisk, so rather than a circle, those would be classed as extreme outliers. That's more than 3 times the interquartile range, so that's really quite extreme. Here we're saying that they're not quite sort of with the rest of the distribution, but they would be technically classed as mild outliers. So you can start to see how some of this information comes together. What you would need to decide is there are some potential issues with the data. Some of the results suggest that those issues aren't too substantial. Others suggest, for example, the test of normality, that the data is not statistically, the data is statistically significant from a normal distribution for the positive effect scores. So you would need to decide what to do about this. So I have a go now at pulling all of those together, and then I'm going to and do that again for the information for the negative effect score. And you can see actually just looking at that you'll probably come to some different conclusions there about the distribution. But have a go at that, pause this video, and then we're going to have a look at the test homogeneity of variance. Okay, so hopefully you've now paused that video. You've had a go at looking at the positive effect, trying to draw some conclusions from that, and the negative effect as well, which I haven't looked through, but you can apply what I've discussed in relation to that variable. What I'm going to do now, though, is have a look at the homogeneity of variance for the positive effect scale. So what this does is it says, are the sort of spread outness of scores, the dispersion of scores for males and females on positive effect, is that roughly the same, or are they quite different? So perhaps one of the scores perhaps for the males are really tightly clustered together, but the scores for the females are all very widely dispersed. So that would be called something called heterogeneity of variance, so difference in variance for the two groups. We want to see if we have homogeneity of variance, which means it's similar. Homogeneity means similar. And we're going to look at the mean, because that's the sort of thing that we've been focusing on so far. So what we'll look at, so we've got based on the mean, we've got the Levene statistic here. We've got two sets of degrees of freedom, and then we have a significance value. So this significance value, if that value is 0.05 or smaller, then the variance of the two groups is significantly different. The one set of scores is much more spread out than the other. If that value is greater than 0.05, as it is here, then we can say that we have homogeneity of variance. The spread outness around the means is actually quite similar, and so we have roughly similar variance in scores for both groups. And for a lot of parametric tests, like independent samples t-tests, that's something you would have to check. In the independent samples t-test, the homogeneity of variance test is actually produced as part of that analysis, so you don't have to look at it separately. But it is good to be able to look at it and make a decision separately if you need to. So have a go at applying what I've just discussed there to the negative effect scale as well. And pause the video and try and write it up, and then I'm going to go through some example answers. Okay, so hopefully you've had a go. You've paused that video and now you've had a go. And so I'm going to look at some example answers. Okay, so what have we got here? So this is, I've just written this in bullet point form. You would obviously, if you're writing this up, this would need to be in full sentences, but it's just to give you an idea of how certain statistics can be presented. For example, a mean should always be denoted, if it's in brackets, with a capital M, which is in italics, followed by a space, an equal sign, another space, and then the value. In terms of the number of decimal places that you need to report to, it really depends on what the variable is. So APA style just talks about being consistent, but also taking into account how many decimal points actually would be useful. So I've reported them to 2 decimal places here. So what we can suggest is, from looking at the descriptive statistics, there's a slight negative skew. We might have a slightly pointy distribution, which is called leptokurtic. But the means and things are similar, so outliers may not be present, but when we look at our box plot, we know that there are some mild outliers, so they perhaps aren't that significant. So for the females, for the positive effect, again, we've got a range of information here, and what we might say is that there again is slight negative skew, but this time a slightly flat distribution, which is called platykurtic, but the mean and trim mean is similar, suggesting that outliers, again, may not be present, or if there are, they're perhaps not too substantial. This is an example of how you could present a figure. So I've removed obviously the border, I've got a normal distribution curve added. the axis of my graphs are both labelled, and I've taken the border off the graph, which is technically APA style. I've got a clear figure number. There should be a unique figure number for each graph in your report or your paper, whatever you're writing up. And I've clearly identified what it's about. So there's male participants, and I've put the sample size in for that on a measure of positive effect, and I've put in the mean and standard deviation of that just to clarify it. So I've got something similar for the females. In terms of laying it out, so I talked about the Kolmogorov-Smirnov test when I was looking at the output, but I'll show you how you can also report the Shapiro-Wilk test. So the Kolmogorov-Smirnov test is actually denoted by a D for some reason. The Shapiro-Wilk test is denoted by a W, so that's what this is here. So I'm looking at the male participants for the first one, which was 160, which is, sorry, the degrees of freedom, which is also equal to the number of participants in this case. That's the value of the Shapiro-Wilk test, and that was actually the p-value reported for the Shapiro-Wilk tests. So for this we can see it's very much statistically significant. For the females, we've got the same layout, so W denoting that we're talking about a Shapiro-Wilk. That would be a D if it was the Kolmogorov-Smirnov test we were reporting. In the brackets, we've got degrees of freedom, which was 198. You can see that in the table if you're looking at it now. We've got the value of W, Shapiro-Wilk, which was 97, and then the p-value, which we know was 0.000. We can't report it as p equals 0 because that is inaccurate. We can instead report it as less than 0.001, so that's what's here. So this would suggest on its own that the data is significantly different from a normal distribution. In terms of reporting the Levene's test, what we've decided was that we hadn't violated the assumption of homogeneity of variance, so we can say that assumption was met. That's the sort of language we tend to use. And this is only for the positive effect variable, so you'd need to look at the negative effect as well. And the Levene's test is actually denoted by an F because it's a type of F ratio, and that's something you'll come across a lot more when we look at ANOVA. So don't worry about that too much now, but what you need to do is to report that, the two sets of degrees of freedom, which I mentioned in the table, in the output, and you do that in the order in which that they're reported. So degrees of freedom 1, degrees of freedom 2, that's what that information is. The value of the Levene's test statistic, which is that, and then the p-value, which was 0.110. And the box plot, so what we've got here, I've taken out the border, I've taken out the background, I've labelled the axes appropriately, and the units are on the axes are labelled clearly as well. And we have some outliers here, and I have another figure caption, that's what it's called, with a number and a clear description of what's going on in that, what the figure is and what's going on. So there's actually a lot to discuss in terms of task 5. I'm only looking at, for the moment, at the positive effect variable. You need to look at them both, and you'd need to sort of combine that and think about what it tells you about the data overall. But what we can say is that the positive effect scale score for males was slightly negatively skewed, as was the data for females. There are no outliers obvious in the female group, but there were some mild outliers for the male group. They weren't extreme though. What we can say is that the variance in the scores on that variable positive effect was similar for males and females, and that actually the means of the male and female participant scores for positive effect were quite similar as well. So there's quite a lot you could tell just from looking at the positive effect. What you need to do is have a go at doing that now for the negative effect score variable. I hope this has been useful. If you have any questions, please post them to the discussion forum. Thank you.